In this lesson, we will learn about binary search. Binary search is more complicated than linear search. But don't worry, I will explain it to you through a real-world example, then you will find it easier than linear search. I assume you have used a dictionary to find the meaning of any word. If I want to find the meaning of the word search in the dictionary, how will I do it? One way is that I start at the first word of the dictionary and then go through all the words in order until I get to the word search. But that's not how we search a word in the dictionary, isn't it? Dictionaries are not meant to be searched like this, as it will take a lot of time. Instead, I will open the dictionary approximately at the middle and check to see whether the word search comes before the page I have opened or after. I know this because words in the dictionary are arranged in alphabetical order. If search comes after the page I have opened, I will go to the middle of the right half of the dictionary and again check to see whether the word search comes before this page or after. I will repeat this process until I have found the right page containing the word search. We search the dictionary efficiently by using the fact that the words in the dictionary are arranged in alphabetical order. This method of searching is very similar to binary search that we are going to learn about. The precondition to using binary search is that the array should be sorted. Let's take the same array that we used in linear search and arrange its elements in ascending order. Like linear search, here too, we want to check if 7 is present in the array or not using binary search. In the first step, we will compare 7 with the middle element of the entire array. To find the index of the middle element, we use the formula start index, which is 0, plus end index, which is 4, divided by 2. This gives us the index of middle element as 2. Let's compare 7 with the middle element. The middle element 5 is less than 7. As the array is sorted in ascending order, it is guaranteed that the elements to the left of 5 are equal to or less than 5. So we can safely rule out this first half of the array from beginning till index 2. 7 cannot be present in this half. Instead, we will focus on searching for 7 in this part of the array. We will find the middle element of this part. Using our formula to find the index of middle element, in this case, start index is 3, end index is 4, we get the index of middle element as 3. Let's compare 7 with element at index 3. We found 7 at index 3 in the array, so our search concludes successfully. Using binary search, we found 7 in just 2 steps, whereas with linear search, it took us 4 steps to find 7. So binary search is faster than linear search. But this speed comes at a cost. The array should be sorted before we can perform binary search on it, whereas linear search works on sorted and unsorted arrays both. Now that we have a basic understanding of binary search, let's look at its Java program in BlueJ and understand its working. This is the binary search program. In this program also, I have used the same array that we used in linear search program. Just that in this program the numbers are sorted, as binary search needs a sorted array to function correctly. After that, we ask the user to enter the number he wants to search in the array. I am adding a few println statements. These will help in explaining the program. I will remove them after the explanation. Let's execute the program first and search for 7 in this array. We got our output. Now we will go over the program and understand it in depth. We can visualize this array like this. Here we first declare a boolean variable found, which we will use as a flag to indicate if the search was successful or not. We initialize it to false. After that, we declare two int variables L and H. L holds the starting index of the part of the array in which we will do the search, and h holds its ending index. In the first step, we take the middle element of the entire array. So L is initialized to 0 and h to the last index of the array, which is given by arr.length -1. Binary search happens in this loop. Note the condition of while loop. It is L less than or equal to h, which means that the while loop will keep iterating as long as the start index is less than or equal to the end index. If start index becomes greater than end index, it means that we have checked all the possibilities but haven't found the item. So the item is not present in the array. Next, we find the index of the middle element using the formula we saw earlier. M becomes 2. Skipping over these println statements that I added for explanation, we come to this if statement, which is checking if the middle element is less than the element we are searching for. The condition is true in this case as 5 is less than 7. So we want to search for our element only in this part of the array. Elements to the left of index 2 are less than n. To search in this part of the array, I will set my start index L to one element right from the middle element. We do this by setting L to m plus 1. So L becomes 3 and h is unchanged at 4. The other two conditions are skipped as this is an if-else-if ladder and one condition has already matched. Program control goes back to the beginning of while loop. Condition is true as L is less than h. Program control enters the while loop to start the second iteration. M becomes 3 this time. Then we check if middle element is less than n. Condition tests false. We move to the else if part and check if middle element is greater than n. Again the condition is false, so we come to the else part. Middle element is neither less than n nor greater than n. This is possible only when it is equal to n. So we have found our element in the array and this println statement outputs the same to the console. As we have found our element, we set the boolean variable found to true and exit the loop by executing this break statement. And with this, our binary search program completes. Let's walk through finding another element in this array. It will make your understanding of binary search crystal clear. I will execute the program again. This time I want to search for 4 in this array. We got the output. Let's try to understand the code now. Like with searching for 7, initially L is set to 0 and h is set to 4. Index of middle element of the array is 2. Then we check if middle element is less than n. Condition tests false this time as 5 is greater than 4. We move to this else if condition and it tests true. This means that we should search for n only in this part of the array as elements from index 2 and onwards are greater than n. To search in this part of the array, we need to set our end index at one index before the middle index. We do this by setting h to m-1. This time the start index L is unchanged at 0. Next iteration of the while loop starts. Value of m is calculated as 0. Then we check if element at index 0 is less than n. Condition tests true as 1 is less than 4. This means that we should search for n in only this part of the array. So we set our start index to 1. Notice that in 2 steps we have narrowed down our search to just a single element, and in the next iteration we will find our element. Program control goes back to the beginning of the while loop. M becomes 1. Both these conditions are false as element at index 1 is equal to n. Program control comes to this println statement and executes it. 4 found at index 1 in the array gets printed to the console. So that's how binary search works. It provides a lot of improvement in searching time over linear search, but with the caveat that the array should be sorted. After learning binary search, Many students get this confusion that for binary search to work, the array needs to be sorted in ascending order only. This is not true. We can sort the array in ascending or descending order. For both cases, binary search will work. Having said that, if the array is in descending order, then this program will need some changes. It will not work as is. Let's change the order of this array from ascending to descending. If I execute the program now, it will give me incorrect output. It is saying 7 not found in the array, whereas 7 is present at index 2 in the array. Let's try to understand what went wrong and what changes we should do for descending order array. In the first iteration, when this if check finds that the middle element is less than n, we search for n in this part of the array. This was correct for ascending order, but now our array is in descending order. So we need to search in the reverse direction. Instead of this part of the array, we need to search in the left part as elements towards the right are lesser than n. So we will change this L equal to m plus 1 to h equal to m minus 1. Similarly, when the middle element is greater than n, we need to search in the right part. So we will change this h equal to m minus 1 to L equal to m plus 1. Let's check our program now after this change. Now it is correctly searching 7 at index 1 of the descending order array. Let's remove these extra println statements that we added for explanation and execute the program one final time. This time I will check for the number 4. We get the correct output for 4 as well. To summarize, binary search works for arrays sorted in ascending order and descending order both. To convert ascending order binary search program to descending order, swap these two statements like this. Let's run this program to make sure that descending order program is giving us the right output. Our program correctly found 4 at index 3 in the descending order array. We will conclude our discussion of searching in arrays by looking at the comparison of linear and binary search. We saw that there is no precondition for linear search. It works on both sorted and unsorted arrays, whereas binary search only works on sorted arrays. In linear search, we go over each element of the array and compare it against our target element until we find the element or we reach the end of the array. In binary search, we use the fact that the array is sorted. We don't check each element but divide the array into two halves and check for the element in only one of the halves. In general, linear search is slower as it requires more comparisons relative to binary search. With that, I hope now you have a good understanding of searching in arrays. Next, we will start discussing sorting in arrays.